Hi, this info session is part of a wider user uptake strategy of the European Commission. One of the aims of that strategy is to stimulate the development and use of innovative downstream applications that incorporate Copernicus data and services. The growing renewable energy sector is best placed to use new technologies and to benefit from Copernicus products and services that offer a full, free and open data to everybody. These data are currently supplied by 6 Copernicus services dedicated to the atmosphere, climate, marine, land, emergency and security domains. In this module, I will show you how to access, retrieve and visualize dust forecast from the Copernicus Monitoring Atmosphere Service, known as CAMS. The aim is to establish the suitability of any given site for solar energy farming. One of the serious problems for the productivity of solar power plants and providers is desert dust. Indeed, dust obscures the sunlight and makes the mirror dirty and thereby reducing the efficiency of the panels. This impacts directly the amount of solar power available for solar energy production and planning, and as well together with the productivity of the solar plants. CAMS offer an aerosol forecast service dedicated to dust, better known as Global Forecast of Aerosol Concentration and Dust. This service gives indication of the desert dust movements and provides daily global forecast up to 5 days of aerosol concentration. The access to these specific products is free but limited to registered users, so it is necessary for you that you register on the European Centre for Medium-Range Weather Forecast called ECMWF that is in charge of the CAMS service. This module is organized in 3 steps that I will address through videos. The first video presents the CAMS catalog and show you how to connect to the ECMWF portal. The second one will show you how to select and download the dust aerosol optical depth at 550 nanometers within the CAMS catalog near real-time products. And the third video gives you some guidance to visualize the results of the selected products in a NetCDF viewer. Here, just an example of how dust aerosol optical depth at 550 nanometer products looks like. We clearly see on this map that the highest concentration of dust aerosol over the largest desert area are in Africa, Asia and Australia. This map of dust aerosol optical depth forecast was delivered in near real time, meaning that this product was available almost instantaneously after the run. Now let's jump to the video. This one shows you how to access the ECMWF portal from the CAMS catalog. First go on the CAMS portal and then we're going to select within the catalog the aerosol parameters. Now we're going to select the global forecast of aerosol concentration dust at 3 bins and we just click on data download. Click on Interactive Data Access to full datasets. Now we will jump on the ECMWF portal. If it's your first time, then you will need to register. But otherwise, you can see you arrive directly on the right page. Then you just have to click on the Continue button. On the ECMWF web application and server, under the public dataset, you just have to select Discovery and Access. Now we're going back to our dataset and we will select the CAMS near real time under the atmospheric composition section. In this second video, I will show you how to select and download dust aerosol optical depth at 550 nanometers within CAMS near real time form. So now we are back on the ECMWF portal and we go to CAMS near real-time form as explained in the first video. Then we select a start and end dates. In this example, I've just chosen 3 days at the time of the making of this video. And then I will select the parameter, which is dust aerosol optical depth at 550 nanometer. I select then my run times. In this example, I selected 2 runs per 24 hours at midnight and noon. And then I can also tailor the dataset I want to download with the forecast steps I need. In this case, I've chosen every 3 hours up to 12 hours from the runtime. And I will retrieve the data in netcdf format. Then you select here your area. In this section, I've chosen Europe. And I choose the right grid format. In this case, it was 0.4 by 0.4 grid. Once the status of the request is completed, based on your needs, then you just have to click on Download or Save As to have your data on your computer. So that's it. We've downloaded the product. To visualize this netcdf product, because it's a specific data format, I suggest using one of these 2 viewers. The first viewer is Panoply. It is developed by NASA and plots georeferenced arrays from netcdf, HDF, GRIP, and other type of datasets formats. Panoply is a cross-platform application that runs on Mac OS X, Windows, Linux, and other desktop computers. You can download it from the link provided in the slide. The second viewer is QGIS, an open-source geographic information system, which is an official project of the Open Source Geospatial Foundation. It runs on Linux, Unix, Mac OS X, Windows, and even Android. It supports numerous vector, raster, and database formats and functionalities. And in the same way, you can download it following the link you have in this slide. So now, this third video gives you some guidance to view the netcdf file with the Panoply viewer. So I've opened Panoply and already loaded the dataset that we downloaded from the CAMS catalog. This dataset contains several variables, and I will select the dust aerosol optical depth at 550 nanometer, which is the one that interests me to manage my solar plant. I will then create a georeference longitude and latitude plot. So I have now a map with the selected datasets. I will zoom over Europe. Sometimes you have to be patient because it's quite heavy datasets, so it can take time to be displayed. But once we have the final visualization, we can clearly see the 2 dust cloud areas that are within my selected area. I can also browse the time series to see their evolution through time. In our case, we had selected the 3-hour time step. So thank you for watching this video, and I hope it's useful.